Dr. Ron England here, and this is EGN3613 Engineering Economics Module 7, Lecture 1. We're going to talk about actually doing analysis with the present worth. Okay, so a few things that you need to look at when you're doing this. This is all about making the decision of will we do something? Will we initiate a project? First thing is looking at, okay, where are you going to get the money? So you're probably familiar with concepts of taking out loans from a bank and then repaying those loans. When you're looking at a project from a company perspective, you're looking at putting in an investment to a project and looking for a rate of return. There's not a lot of difference monetarily when you're looking at these two when you do the calculations. So it does make life a little bit easy for you in the calculations when you're doing these calculations. So let's look at something here. Let's suppose your company is considering to buy a new system. It's going to cost you $650K. Now, years 1 through 8, it's going to cost you $53K in maintenance, but you're going to make some money off of this, $215,500 in years 1 through 8. Now, looking at this project, say the lifespan of 8 years, it might be longer, might be shorter, but it's a lifespan of 8 years. Is this worthwhile? Well, let's look at some of the ways we can do this, calculate the net present worth. So we can kind of look at the cash flows here. Years to year, year 0, you're putting out money. But years 1 through 8, you're making money and putting out money. But that's pretty straightforward to do because all you really need of those cash flows is the net. Well, that's pretty easy. It's just inflow minus outflow. We can easily move that direction. So looking at the cash flow, the timeline, okay, these two timelines are the same. The cash flow, since they're in the same year, of the 215.5 minus 53 is just 162.5. Well, this is pretty easy because what you've got is you've got a present value of a present amount, 650K, and you've got a series of essentially 162.5 over 8 years. Well, that's a straightforward calculation, and we know the interest rate, so bam, that's easy to do. You do the present worth of what you put out, you put that over 8, so that's a P over A, and the rule is simple. If the present worth is positive, go for it. Present worth is negative, don't. Now realize this is also at an assumed interest rate, and that does actually make a difference. So when you're looking at these, you can say, well, the decision point isn't that hard. Okay, what's hard? The assumptions. Okay, decision point is calculate present worth analysis is straightforward. You look at the present worth of the investment and see if it actually makes sense. This one, by the way, had multiple ways that you could do it. You could do, this is straight as a P over A. 2 ways to do it, really straightforward. So concept of payback period is simple. How fast are you going to make back that money? Now, in this case, we're going to talk about something called a cumulative cash flow. Okay, it essentially allows you to see where you're going to get to where the money comes back. Now, in a standard payback period, you simply just put the money there out and you're not discounting the money. So it's not, in many cases, considering the time value of money. However, it can be done. So a simple payback period is just, let's say we got these specific cash flows. You put $105,000 into a new machine, but you made $20,000 off the old machine. So you have a cumulative cash flow in year 0 of negative $85,000. Then each of those years afterwards, you're making a prescribed amount, 15, 25, 35, 45, 45, 35. And you can see that between 3 and 4, you go from negative to positive. So your payback period is somewhere between years 3 and years 4. Okay. Well, again, that's not including any level of discounting for the interest rates. Okay. You might have to do that. You might want to do that. But right now, simplified, okay, you're simply just adding and subtracting. You start with the negative 85 to start with, and each year you're going to go ahead and add in that amount that you made. So 15,000 plus negative 85 is negative 70. 25 add to negative 70, negative 45. Straightforward, easy calculation, and you reach payback period. You can also plot this guy, pretty easy to do, and you can actually see that the payback period is roughly 3.2 years. So you're looking at sometime probably in March where you break even with this, assuming no discounting for the actual time value of money. Now, of course, you probably want to actually look at it with a discounted cash flow. And there's a real good reason for doing this, because every single situation when you've got the ability to make an investment with money, you've got the ability to make alternative investments. And the time of return, the time that you get the money back, will make a difference. So you're going to discount. Well, how do we do this? We've got a number of ways to do this. This one, what we're going to do is we're going to do a discounted payback period calculation where the cost of the funds is going to be flat $15,000. So these cash flows come in. However, they're not. What we're going to do is we're going to take that $85,000 and say that's the initial cost of that fund. And note that that cost of funds makes that payback period go back. The cumulative cash flow now changes. Okay, it's now between 4 and 5 years. Still positive, okay? Still between 4 and 5, you're still doing okay. Still positive, but okay, well, not as good as the last scenario. But we did take the fact that you've got 85,000 that's right there with the cost of that of the 15%. So that's with a payback period calculation. So let's go through another example here and actually look at this in a little bit more depth. Let's just try a different example right now. But you can see how that was actually straight. It's not a terribly difficult calculation there. And you can actually see that we took into account, you've got the 15,000, it's 12,750. Go over here to, you add that to you got that to the 12,750. It's the difference in the two. So now you take this cumulative cash flow is now less by the 15 minus the 12,750. So that comes off the top there. So what I'm saying is there's the negative 85. You've got 15,000 positive, negative 12,750. Okay, now it's negative 8,270, which is the difference between these two. But here, do it again. Okay, the 82,750 now comes in here, it has that a 15%. Boom. Okay, now it's the difference between this one and this one. You're looking pretty good here. It's negative 70. And okay, I think you can see the calculations. I'm going to do that again for everybody. Start with a negative 85. Okay, 15%, 15% of the 85 right there, negative 12,750. Okay, cash flow positive 15,000. The cost of the money was negative 12,750 for that first year, and that left you with negative 82,750 here. And you just repeat from year after year. Now note that I had to take this value. This is the amount that's actually in the cumulative, essentially the cost of that money is this money right here from the year before, and we just bring it down, and eventually we come back to a positive number. Looking at another way to do this, let's take an example of the Federal Express. We've got this thing here. We're going to do an initial investment cost of $150 million with an expected savings of $20 million per year. Now I'm just going to do straightforward calculations using the interest equation for the individual years. And the first one is just simply the flow with 0. There's no discounting involved in here whatsoever. Okay, so look at that. At between years 7 and years 8, break-even period. However, now we're going to just try this at specific interest rates from 5 to 10. We're just going to try different ones. And in this case, I'm calculating, use the standard equation. Now in this case, what I'm doing is I'm saying I'm going to be calculating the amount of here as a present value to compare to the negative 150, which is essentially the equivalent of the same thing as taking the negative 150 and calculating the cost of funds. Okay, only in this case, I'm actually taking into account the amount that we're making. And note, boom, 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 the break-even period gets later and later as you increase that interest rate. The cost of that initial funds is going to cost you more. Or what you also can say is the present value of, in this case, what we did for the present value of the actual amount that you made is less for each of those later years. So it takes less off the top every single year. And at the higher interest rates, it takes even less and less off the top every single year. If you've got a question about this, then about the calculations, what I didn't show you the equations. What I'm saying is that I'm discounting the amount made in any given year to a present value and using that present value to come off of the initial investment. I could also take the initial investment and look at the amount, the cost of the financing that I could add to it So another way to do the analysis. Comes down to a number of questions though. Is it worth the investment over 10 years? How long is it going to take you? And a big question, what interest rate should it, what's the interest rate? So here, you're going to see this next one in your discussions. Mr. John's investment problem. So Mr. John Smith put $800,000 of his money into putting together a little power plant on his property. And his annual power sales after taxes is estimated at $120,000. Okay, put in $800,000, got $120,000. Service life of $800,000. Service life of 50 years. It's a long time. Now, question here. When will he make a profit? That's the question. When will John Smith make a profit? Okay, again, I've got a few pieces of information that are going to have to help you out here. The $800,000 was actually at different periods in time because it took him 10 years to build the plant. This first part's easy. These numbers need to be made into a present value. You need to know what it is here at time 0 when you started making money off of this thing. So there is a process. You're going to calculate the present value of expenditures. Okay, now you've seen two ways to do this. But what I did do is I said, you know what? I don't know what the interest rate's going to be here. I need to look at specific scenarios, and maybe we should look at the likely scenario associated with the interest. There's another possibility is cost of power changes. Okay, it inflates, and it's possible to inflate the cost of power and say, hey, well, you know what? We're going to charge more for that power in future years. Well, you're going to see this one again. So I'm not going to answer it. And we're going to let you, as a group, compare and look at different possibilities and what you think is the most likely and best way to go ahead and say, is this a good project? That's it. On out.